I know we all have cell phones. I want to hear, well, I always have my phone. I will give you every excuse in the world where you don't have your phone, it's broken, it didn't charge, you dropped it in a puddle, blah, 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 blah. Can't use your phone, okay? Well, then we have calculators on the truck, okay? Well, you never checked it, and guess what? The batteries don't work. Well, it's solar. Well, it's still not working. You gotta do math by your head, all right? So we're gonna go over some basic stuff. Okay, by the end of today, I can guarantee you 1 + 1 is going to equal 3. Just so you know, heads up. All right, so your basic formulas. Do we know the basic formulas? Ooh, let those hands fly. Oh, I did them 2 months ago. I did them like 10 years ago, and I still know them because they're still in my phone. Joe, do you know them?
Yes.
Yeah, because you got to know these. You got to commit them to memory. Okay, so the volume that you want to give, so the drops per minute, just basically how much you want to give for a fluid volume. So your dose, all right? So you've got your volume. It's going to be times it by your desired dose. So however many milligrams or whatever you want to give of that particular drug, okay? And that's all going to be given over the dose on it, all over the dose on hand, okay? So that is going to, when you're trying to figure out how much volume you want to give. Okay? So when would you guys think you're going to use that type of formula?
IV boluses.
Yep, just an IV bolus. That's all that is. That is your IV bolus formula. Okay? Do we all have that one written down? We're going to be using these momentarily, so. So, when we're looking at number 6, all right? So, your order to administer an epinephrine 1/1000 for the PD patient who weighs 50 pounds. All right? So, right off the bat, what do we got to do?
Convert that to 50 pounds.
Convert that to kilograms. So so there's a couple different ways we can do that.
Divide by 2 or 10%.
So divide by 2, take 10%, okay? So we have 50 pounds. Half of that is going to be what? 25, very good. All right? What's 10% of a number? So in this scenario, guys, every number is going to have a decimal point after it. For when we want to take a percentage, however many zeros you have. So we've got 10%, how many zeros?
1.
1, very good. Just move the decimal point to the left. Anytime we're multiplying by a 0, it's the same thing. So we're going to make 25 and we're going to times it by 10. When we multiply, we move it to the right. That's all you got to do. Okay? So, obviously take away 2.5 from 25, which is going to give you what? 22.5. Quick, down and dirty way of doing your pounds to kilograms. All right? Do we need a calculator for that?
Not that one.
Not that way. Okay, fine. All right? Well, I want to do it the other way. So now you want to take 50 and divide it by 2.2. Well, what's always going to be your biggest problem? That damn stupid what?
Yes.
Decimal point. So how can we get rid of it?
Multiply both by 10.
Multiply both sides by 10. Decimal point moves over to here. It's 500. Does that just make your math a heck of a lot easier? Because why?
Hold on.
The decimal point's gone. Okay? So 22 now goes into 50 how many times?
Twice.
Twice. So we're left with 44. Like, is your math working? 2 times 22? All right. So what's left?
6
6.
times 60.
Bring down to 0. How many times does it go into 60?
Twice.
Still 2. Left with 44. And what do we got left?
60.
16. Right? Now put the decimal point back in. Bring down to 0. And what do we got?
Goes in 7 times.
about 7 times, give or take. Simple, easy way to get rid of that decimal point. Did we come up with the right answer both times? 22, 23 kilograms, depending on where you want to round up. 10% is always going to, the half and 10% is the quick on-the-fly medication. The quick on-the-fly, figure it out. If you got to be more precise, I know a lot of medics that they have to do it this way because they're just math. They love math, but they're sitting there trying to figure this out forever. Okay, we good on doing the 2 different ways. I don't want to hear I have a calculator, so get over it. You cannot use that excuse when I teach you med math. All right. So, question so far? Yes.
Can I have one of those papers? Yeah, I need one as well. I'm gonna at home.
Anyone else need a paper? No? All right. So, using this lovely formula now, guys. All right. So, we know our patient weighs 22, 23 kilograms, right? Does it really matter what we're using? Not really. Okay. But obviously, if the patient were completely off on our numbers, say that the patient actually weighed 75 pounds and we're using 22, is that a big deal? Yeah. Absolutely. All right? Because once again, it's a guessing game for weighing a patient, right? Because every patient's going to look differently standing up versus laying down. Because when we lay down, what happens to the patient? They just spread out. Yes, I know. Okay. It is what it is. All right? So, you're going to give your dose. The drug is supplied in 1 milligram per ml. The proper dose, conveniently gives you the proper dose, is 0.01 mg per kg. So we need to come up with the desired dose. So your dose is 0.01 mg per kg, milligram per kilogram. So we know our weight. Okay, so we know our kilogram weight is 22. And we want to multiply that by 0.01. So what are we going to do?
Move the decimal point to make it easier.
Very good. Which way?
To the right.
Okay. Yes. But we have a simple, easiest way. We have 2 numbers behind the decimal point.
Yeah.
Anytime you multiply a small number by a big number, what do you think the answer is going to be? Small or big?
Big, maybe?
Small.
Small.
Okay? Because it's cutting the number basically way down because we have 2 decimal points. So, easiest way to do this is when you got 0.01, 0.02. Anytime you have a 1 in when you're multiplying, what are you going to get for an answer? The number that you had. Then you just got to figure out decimal points. So all it is you got two spots, 0.22. If this was a 2, get it? 3, that's all you guys got to do. All right? What's that? I know, isn't it? Because I haven't done. When was the last time you did this stuff?
6th grade?
6th grade, give or take. How many years ago was that? Well, at least we're giving you credit because you're actually one of the older students in the class. All right. It is what it is. We have kids coming out of high school and said, "Oh, I haven't done this in like 10 years." I'm like, "I haven't done this in 30 years."
I haven't done it in 25, 26.
Exactly. All right. It's that simple, guys. Can you do that simple stuff in the back of the truck? Yeah. Oh, hold on. Come on, someone give it to me. I want to use my phone. You can't, because you forgot it at the station. Okay? Because 3 o'clock in the morning, can you actually get outside in your truck and be completely fully awake at 3 o'clock in the morning? I can't. I didn't do this morning, because guess where my phone was? Sitting on the nightstand at work. And no, we don't have calculators in the drug boxes. Because we don't. Alright? But you got to know this stuff off the top of your head. So, we know our dose was going to be 0.22. So just using the formula, so that the drug is going to be supplied in what? What was the drug supplied in?
1 milligram.
1 milligram per 1 ml. So the volume we have is what? 1 ml, times my desired dose, 0.22, all over what? 1 milligram. All right, if you can't figure this out, 1 times a number divided by a number, 1 is going to be what? The number. So your volume, the milligrams, all right, cancel out. All you're left with ml, ones cancel out, so 0.22 mLs is going to be your answer for number 6. All right? Any questions on that one? Yeah, this one next. You just want to give fluid over time. Okay? So these are your patients, your burn patients, your patient that just needs a fluid bolus. All right? You're just given so many cc's, mLs per hour. Okay? So that formula is going to be drops per minute is going to equal your volume times it by your drip set all over time. Okay, the volume's got to be in what? What do you think the volume should be always in?
Milliliters.
Milliliters, very good. All right, so there's your mLs. What's your drip set going to be for just giving fluid over time? We're using a micro or we're going to use macro for this?
Macro.
Macro set, very good. So what are the versions of the macro sets that are out there? What do we got for numbers? 10, 15, 20. Very good. So you want to use one of those. All right. So on number 8, we're using the 10 drop set. So we're in number 8. We want to give the IV drip run to run 250 mLs per hour. Macro set's going to be a 10. Okay. So there's your 10. All right. And time. What do you think time needs to be in? Minutes. Very good. Okay, you need to break it down to minutes. So, doing that formula, guys. So, IV drip rate's going to run at 250 mLs per hour. Times it by your drip set. All over 1 hour. But like I said, we need to convert that to minutes. So 1 hour converts into
60 minutes.
60 minutes. Very good. Now, right now, if you try to do 250 times 10 times 60, how big's your number? Oh my God, it's like lots of zeros, right? I'm serious, right? You guys can start narrowing down that equation to make it easier for you guys. When you have so many zeros in the denominator and so many zeros in the top, 0 times a 0 or 0 divided by 0 is always going to be what?
0.
Thank you. It's not going to give you anything but that. So, start canceling out zeros. I have 1 0, 1 0. So, how's my number now? A lot smaller? Absolutely, okay? Can we do this? Can we reduce this down anymore? You guys remember what reducing is?
5 both by 2.
So we can divide both by 2. All right? So now half of 250 is what? 125 all over 3. What are we doing to our number? Just making it smaller. Have we used a calculator at any point in time so far? No. Yes, I know you haven't done this in 6th grade, guys. I get it. So 125 divided by 3 now. 3 goes into 12. 4 times. And then you're left with just 5. 3 is going to go into 5 how many times? Once. Okay? You're just left with 5 left. Then we got 3. We got 2. You can add your 0 now. And you're left with 20. 41.6, right? You can round up to make it 42. All right? And there's your answer for number 8. Okay? You can do it out to 41.67, I actually did it out, or we can just round it up to 42. Any questions on how to calculate just fluid over time? Do we use a calculator? No. All right, good on this one?
Is that 42 drops per minute or per
42
hour?
drops per minute.
Okay.
Yep. So how many drops per second is that?
2/3 of a drop.
It's give or take, yeah. All right. Good. Questions? All right. Still with me? All right, now the most biggest challenge you're ever going to have. What's that one? Infusions. Very good. So, with infusions, how many of you guys do you know if your paramedics are carrying pumps? So some do. Awesome. It's now mandatory in Massachusetts to have pumps, but we only have to have them because one medication. All right? It's kind of silly, but it's a very, very sensitive medication. It's norepinephrine, Levophed's back. Okay, so that med has to be given via pump because that's a big deal with Levophed. Okay, dopamine, it wasn't such a big deal. Epi infusion, not as bad, but Levophed, that I think, no, yes, no, that's a big deal with Levophed, the norepinephrine. So that is why we're getting pumps. Trust me, guys, I've worked with the tons of pumps that are out there over my years as a paramedic. They do everything for you. They calculate everything, but it comes down to what? You put it in the right numbers. Because if you put in the wrong numbers, what's going to happen? Exactly. So unfortunately, it still comes down to what? Operator and math. Because trust me, operator error with the pumps is bad. Yes, we have to have them preloaded, but still a doctor can override the pump and give you something that you're not used to. It's not programmed in that pump because the patient needs that much medication. I've taken multiple meds running. I'm sure Joe has done it too. All right, well, we're doing critical care calls because why? Critical care is not available. If patient still needs to go to Boston and MedFlight's not available, who's taking them? Hey, it's still us. Unfortunately, what rolls downhill? Stuff. Very good. Good job. We're always going to be at the bottom. All right? And trust me, if your med control says take the patient, you're taking the patient. There's nothing you can do about it. All you do is you make sure you get an additional paramedic to be in the back of the truck with you to help you with this patient because why? They're critical. It's that simple, guys. So, all right, there's tons of different sheet ways out there, definitely for the other two drips we use. What are the other two drips we commonly use? Dopamine and epi. Okay? Sometimes the epi infusion is already made for us. Sometimes we just make our own epi infusion. Okay? So, we'll go over the clocks momentarily. So, this formula now, guys, drops per minute is going to be your volume, times it by your drip set, times it by your dose. All over your dose on hand. Okay? So, this is when you could be making your own infusion. This same formula is also your dose, your desired dose, times it by your drip set. All over the concentration. Same formula. All we did was combine your volume and the dose on hand to give you your concentration. So when you know your concentration, dopamine, your standard concentration for dopamine is going to be what? What do we learn? What's that? Not 220. 1600, okay, mics per ml. So when you know your concentration, there you go, you can use the reduced formula down. When you don't know your concentration, you got to use the bigger formula. Obviously, with the bigger formula, your number's going to be what? Bigger. Really big, okay? Versus this number, we've started to narrow it down a lot, okay? So, when we don't know all right, when we don't know, so basically for like an epi infusion, all right, what's our drift set for any time we're going to be giving medication over time? 60 drops set. Very good. So, say we're going to make an epi infusion, okay? You need a couple things. You need epi and a bag of fluid, okay? What type of epi, though? What type of epi do you think we're going to put into that bag?
1 to 10,000.
Not 1 in 10,000. The other one.
1 to 1,000.
1 to 1,000. What's stronger, 1 to 1 or 1 to 10?
1 to 1.
Very good, 1 to 1. Okay? So, we're going to take that milligram. We're going to stick it into a 250 bag. Okay? So, that volume is going to be in milliliters. So, your 250 bag. Times it by your drift set, which is going to be what? 60. Times it by your dose. So, what's your desired dose for your epi infusions? Okay, have you guys really got into this cardiac yet? 2 to 20 mics per minute, starting at what? Not 5, 2 to 4. Okay, that's how our starting dose for an epi infusion. The range is 2 to 10 mics per minute, starting at 2 to 4 mics per minute. It's not a weight-based drug. So we can put a 2 here, okay? And then our dose on hand is 1 milligram. Well, we need to convert that to what? Mics. So 1 milligram equals 1,000 micrograms. Okay? So when we cancel everything out, we're only left with drops. All right? So, once again, let's make our lives a lot easier. How many zeros in the top? How many zeros in the bottom? Come on, guys. It's not that hard. 1, 2. You can use your fingers and toes. All right? So we got 2 up top, 3 on the bottom. Right? So we can get rid of 2. Very good. All right, can we reduce this down even more if we wanted to? Absolutely. So we can get rid of, we can actually reduce this down. This conveniently becomes a 1, and this becomes a 5. Once again, making your lives a lot easier. All right? So 25 times 6 is going to be what, guys? What is it?
150.
150, very good. All right, 150 times 1. Hold on, slow it down. All right, 150 times 1 is 150, and then we're all left over 5. 150 divided by 5. 30 drops a minute. Okay, so 30 drops a minute. All right, so using that, so now we're giving you 30, the patient's getting 30 drops a minute. Okay, so my patient is getting 30 drops a minute currently. How many drops per second? 1 drop every 2 seconds. Very good. Okay, those lovely clocks. They're the best thing in the world. Because A, you can start treating your patient just by the clock. Right? I know my patient needs epi. I want to start giving them 2 milligrams. I can easily know right now it's 30 drops a minute. Okay? That way, you can start treating your patient. Then do the numbers. All right? Because obviously, it's what sometimes if we're using dopamine, it's weight-based. We want to make sure we're giving my patient enough dopamine. Okay? So, it's your standard clock. Just apply the right medication. You can use this, the ladder clock, the dopamine clock. So we know our concentration is going to be epinephrine. All right? So, you've got your clock. So this is obviously 0 plus 4, obviously 0 and 4 when we make the whole way around the clock. 1, 2, 3. 1 drop is going to give you, 1 milligram of epi is going to give you 15 drops a minute. 2 conveniently gives you what? 30. This is 45, and then this is going to be 60. This is the 60 drop set. Do our numbers match? Yeah. That's an epi infusion. When you don't know the concentration, you can figure it out. When we do know the concentration, you can cheat and use the other formula. Okay? So if we wanted to figure out the concentration now, to make that, and we know we put 1 milligram in a 250 bag, can we figure out my concentration? Yeah. This is actually 1,000 divided by 250. Number goes there. When you know your concentration, you can easily cheat and save a step. If not, you can easily figure out your concentration. Okay?